There are countless intriguing phenomena and enigmatic locations scattered throughout the vast expanse of the universe. NASA has discovered a location in the vast expanse of the universe where there is a complete absence of matter. That idea seems quite far-fetched since the concept of nothingness is not supported by scientific evidence. These locations are devoid of any substance, which can be quite unsettling. There are numerous intriguing questions that come to mind, such as the mysterious absence of matter in these locations or the astonishing growth of these places. Scientists have been studying these enigmatic locations for over 3 decades, trying to unravel their secrets. And now, for the first time, researchers have discovered a completely novel solution to this inquiry. The answer is both captivating and alarming. Deep within the vast expanse of the cosmos, scientists have made a remarkable discovery: vast expanses of star-filled deserts where otherwise the light of millions of galaxies and countless stars would shine. There is nothing but darkness and emptiness. These mysterious space-time anomalies not only stand out in a strange way from the rest of the cosmic environment, but they also seem to rise above the known laws of physics and possibly represent a completely new phenomenon. Due to the conspicuous absence of matter, these cosmic deserts of gigantic dimensions contradict the usual predictions of Einstein's relativity equations and raise questions about the uniform structures of the cosmos. Above all, the size of these fields in which there appears to be nothing contradicts the general rules of cosmology. But the size not only breaks our physical rules, it also quickly pushes your imagination to its limits. These possible holes in the fabric of space-time are gigantic in scale. They stretch over millions of light-years, a dimension comparable to the largest known clusters of galaxies. By comparison, a single ray of light, almost 300,000 kilometers in 1 second, would take thousands of years to cross one of these enormous empty fields. These regions are so vast that they could exceed in scale some of the largest structures in the known universe, such as the Virgo galaxy cluster or even the Laniakea superclusters. They represent a mysterious absence because imagine galaxy clusters like the Virgo containing several million galaxies, while there is hardly any matter to be found in the collections of ghostly nothingness. But the scary thing is that these areas are not completely empty. Researchers have found individual galaxies that exist like lonely and deserted patches of light in the middle of a never-ending desert and wasteland. The existence of these galaxies makes the places with nothing in the universe even more eerie. We are faced with a cosmological puzzle that could dramatically change science and our view of the known universe. What causes these vast empty areas in the fabric of space? Are they the product of natural cosmological processes, or could they point to phenomena that we have not yet fully understood? The structures that cause scientists such distress are gigantic cosmic voids, empty spaces of such epic proportions that they cannot be there by chance. They must have a special function, or they are the consequences of incredibly brutal processes in the cosmos. Gigantic empty spaces between galaxies and galaxy clusters are one of the most puzzling phenomena in the currently known universe. Even black holes are better researched than these voids. A particularly remarkable example of these structures is the void which NASA has described as a gigantic void measuring millions of light-years and almost completely devoid of visible matter. This void was first discovered in 1981 by an astronomer named Robert Kirshner and is one of the largest known voids. This mysterious void stretches for around 330 million light-years. Kirshner and his team called their discovery the Great Nothing. At the time, the astronomers thought they had stumbled upon a unique anomaly. Little did they know that this void was not the only one. Today, many of these voids are known, and some are even more gigantic than the Boötes void, such as the Eridanus void, which stretches over 500 million light-years, and the Northern Local void, which also reaches impressive dimensions. In total, there are thousands of these voids, which together make up a significant part of the universe. When we talk about emptiness, darkness, and nothingness in the universe, the terms black hole, dark matter, or dark energy might come to mind. It's a fascinating question whether and to what extent these phenomena are connected. In fact, some theories suggest that the size and distribution of voids could give us deep insights into the nature of dark energy. Dark energy is thought to be responsible for the accelerated expansion of the universe, but it may also be mysteriously involved in the formation of these voids. We know from particle physics that where there is no visible matter, there is by no means necessarily nothing. There are very probably invisible forms of matter that we cannot see simply because they do not emit light. In regions such as the voids, unknown forms of dark matter could be more present than in other areas of the universe. For this reason alone, these structures are highly sought-after objects of study. To make the dimensions of the voids more tangible, we imagine the known universe as a soccer field. Galaxies and galaxy clusters would represent small patches and clusters on this field, while voids would take up most of the area. Clusters of galaxies and superclusters make up perhaps only 10 to 20% of the mass of the universe, while the voids and the spaces in between make up the rest. This reminds us that scientists say that the universe is made up of about 85% dark matter. So, are these empty spaces and their distribution something like mirrors, showing the distribution of matter in the universe on a large scale? And can the voids help us to understand effects such as gravity and dark energy? Voids allow astronomers to study the effects of gravity in an environment free from the direct presence of large amounts of visible matter. However, the gravitational effects in and around voids only reveal themselves to us through the motions of visible matter, for example, the few galaxies within these voids. Further gravitational effects become apparent when we study the light from objects behind the voids. As large as a void is, at some point, it comes to a spatial end, and if there are galaxies behind the void, their light penetrates through the void to us. Some observations can provide information about how gravitational forces act over large distances and with little visible matter, which in turn allows conclusions to be drawn about the distribution and properties of dark matter in the void. Voids are also ideal for studying their shape and thus the expansion rate of these huge empty spaces, which in turn allows conclusions to be drawn about dark energy. To this end, scientists are studying the geometry and dynamics of the voids in great detail. Now imagine that our galaxy is located within the Boötes void. Then let's travel back to the time when astronomers first realized that our Earth is a planet within a galaxy. It was the astronomer Edwin Hubble who first realized in the 1920s that there were more galaxies in the universe. Hubble saw the Andromeda Nebula and other similar objects for the first time in 1923. Shortly afterwards, Hubble succeeded in proving that these nebulae were independent galaxies outside our Milky Way. This discovery was, of course, phenomenal, and you can imagine how it changed people's cosmological understanding at the time. Since then, the universe has become bigger and bigger. Today we know of an estimated 2 trillion galaxies and look over 45 billion light-years in every direction with high-performance telescopes. If Hubble had lived within a galaxy in a void, he would not have been able to discover another galaxy in his lifetime. He would have seen nothing but blackness and might have thought that the universe outside a collection of stars was a vast nothingness. It wasn't until the 1960s that our technology was so good that we could see as far as a scientist in a void would need to see in order to spot the first galaxy outside his own. A fictional scientist inside the void would have the opinion from his vantage point that the universe is very sparsely populated. In the 1980s, we might have come across the first cluster of galaxies, and would have been surprised to publish in a scientific journal that there are mysterious clusters of galaxies in the universe for which the science of this fictitious world has no explanation. For us, the picture is exactly the opposite. We humans began by studying our own world, which for a long time was the center. Eventually, we realized that all stars are other suns, and that there may be planets there too. Our science has grown linearly from our point of view, and new, initially inexplicable discoveries have provided new clues as to what the world and the universe are really like. The voids show us that our view of the universe is still very one-sided, and that what we consider normal may be the exception elsewhere. It sounds crazy, but there is some evidence to suggest that voids have not existed since the beginning of our universe, but were created later through collisions so violent that the very idea of the forces at work there challenges the limits of our minds. Calculations of certain spots in the void have shown that two universes could theoretically have collided at these points. This would mean that voids are created where parallel worlds collided. When two black holes merge, enormous forces are already at work, as well as when stars explode or galaxies merge. But can you imagine the forces that are unleashed when entire universes collide? This theory has not yet received the recognition it perhaps deserves. as many conservative scientists do not like the idea of further universes or the multiverse. Nevertheless, the voids could be the first important clues here. Traditional scientists explain the existence of voids by gravitational interactions of matter. Matter becomes extremely dense in some regions, and empty zones are created elsewhere. Remarkable structures resembling geometric cylinders have been discovered in some known voids. These areas indicate that even in areas that at first glance appear to be free of any matter, structures and orders can exist under certain circumstances. These cylindrical zones within the voids are usually interpreted as the result of mergers of smaller voids. The large voids could, therefore, have been formed over billions of years from many small voids. However, this still does not explain the mystery of what voids really are and why there is hardly any matter in them.